but I've been in the far north for something like 30 years and involved in regenerative agriculture for around 20 years. Yeah, since right at 2000, 2001, something around that time. So I've got a couple of companies. The one I'm here representing is RegenAG, regenerative agriculture, something my wife and I started for the purpose of delivering educational events in regenerative agriculture methodologies about close to 15 years ago now. And then I'm also in the process of actually establishing an organic fertilizer business as well. But we're here to talk about soil health, in particular within the context of, I guess, grazing operations, where many of you would be joining us from that context. So I wanted to start with, I guess, defining what it is that we're actually talking about when we're talking about soil health. And a good place to start, I think, is the difference between dirt and soil. So dirt simply means that there's no life, there's only minerals. So, you know, as I'm sure you're all familiar, you've either got a bit of clay, a bit of sand, a bit of silt, or a combination of all. We've got, you know, clay loams and sandy loams and silty loams and alike. But that's really just the physical and chemistry aspect of soil. But if you don't have the biological component, then it's really not soil as much as it is dirt. Now, soil, on the other hand, that has the life component. So you still have the physical characteristics of the soil, you know, structure and aggregation and bulk density and compaction and those type things. And you've also got the chemistry component, which you'll see from a soil test that you've looked at. It shows pH, or how much sodium you have in the soil, overall nutrient availability, the ability of that soil to hold on to nutrients, the nutrient holding capacity, all of that is in the realm of chemistry. And then we've got the biological component. So the biological component is made up of those organisms that you can and can't see in the soil. So microorganisms, scientists call them microorganisms because they're so small. That's why they're called microorganisms. The amount of organic matter in your soil then, you know, determines in part how many microorganisms that you have in your soil, because that is their housing and food source. And it really determines then the degree of activity in your soil, the amount of nutrients that get cycled and made available to plants. So soil is I guess, a living medium, is the intersect between those three components: the physical, the chemistry, the chemical, and the biological component. And of course, as this photo here depicts, you know, within the soil, we've got various gases, carbon dioxide and oxygen, there's water, there's air. And in the center, we've got the one thing that we all want more of in our soils, and that's that black cream cheese looking structured soil. And that's really high levels of organic matter, or humus. Not hummus, that's what you make with chickpeas. Humus is that rich black, fully decomposed organic matter that, you know, it really is an indication that you've got extremely healthy soil. The more humus you have, the healthier soil is. And really, soils then, with that biological component, they are the primary managers of our land-based ecosystem. So everything that you see above that cut, that's what these soils are servicing. They're growing pastures, they're growing animals. You see crop there in the background, you see tree systems and alike, but all of that above the ground is purely dependent upon what's happening below the ground, between those three components of the soil. So another way I like to think of it is like three legs on a stool. You've got the physical, the chemical, and the biological. If one or more of those are kind of not adhered to or focused on, as many people would argue has been the case over the last 50 or 60 years, where only one of those legs on the stool has been the main focus, and that is chemistry with N, P, K, and S and other trace minerals, then the stool becomes very unstable. So I wouldn't say that any one of those three legs is more important than the other. They're all equally as important as each other. And any one of those legs that's not quite at the optimal health that it could be, whether it's, chemistry with the pH being out and minerals not being available, or biological, where you just don't have the microbial life in the soil, or it's the physical characteristics, maybe you've got compaction. Any one of those things is not ideal, then the system becomes a little bit unstable. And I should also say that the physical and the chemical influence the biological, and likewise the biological influence the overall chemical structure of the soil. And we'll talk a little bit more about that later. So there's nowhere that you can go on the planet that doesn't have soil that has plants. So basically, the only places on the planet that you don't see soil is where you don't have plants. So plants grow soil. So without plants, we can't grow that top 6 inches of the Earth's crust. And most definitely, the interactions between plant and animal have built the richest, greatest, deepest soils on the surface of the planet. You think of the Great Plains of America with the bison, as we see depicted here, with African savanna, where you've got these large herds of multiple species of different animals that have migrated across the landscape, chewing grass, generally chased by something that wants to eat them, which keeps them moving forward. And that great migration over many hundreds, if not thousands or more years, has created these incredibly deep, rich, beautiful soils. Now, over the last 150 years, growing corn, soy, and wheat, and as we see here with cultivation and taking those solar panels off the surface of the landscape, no longer having the root systems that are holding onto that soil and building that soil. The US, as many other places in the world that have followed similar type practices, are also facing similar type issues with topsoil loss, erosion, and declining fertility and the like. So there really is no landscape. I always like to say that there's no such thing as a vegetarian landscape. A vegetarian landscape doesn't exist in nature. If you look at a lot of our cropping country, particularly down south, it really has been turned into a vegetarian landscape in so much as all the animals have been taken off. And so you don't have that animal plant interaction anymore, meaning that a lot of external inputs need to be brought in to keep the system healthy, keep the system growing. And the beauty about animals is one of the great things that they do is they cycle all of the organic material. So as those plants grow, if you weren't to eat them, if livestock were not to consume them, as I'm sure you've seen on your properties, you'll see all of that above ground vegetation start to lignify and go grey. And in many cases die. And that's very much an oxidative process where the carbon is going up into the atmosphere. And as that continues year after year, the emerging seedlings or the emerging growth of the following season doesn't get access to sunlight, and therefore it can't grow, and you'll get wider and wider spaces of bare ground because all of that organic material is not being cycled. And particularly where we've got this wet dry season scenario like we have in the far north, livestock with their stomachs being wet and moist all the time is a fantastic way to cycle all of that organic material. And of course what they pop out the other end is roughly 14 tonne a year of NPK, which is about a 3-to-1. So if you've got 1,000 cows, that's 4,000 tonne a year, which is about 420 tonne of nitrogen that's being cycled through the gut of an animal. So 75 to 90% of what they're consuming is getting popped out the other end in the form of dung and urine, and their hooves obviously disturb the soil surface. So, there's a lot of detail in this, and we'll get into a little bit later. Obviously, the amount of time and when they're accessing certain areas of the property and certain paddocks is critical. But one thing that livestock do is that they will break the surface of the soil so that you don't end up getting that capping that can form on the top of soils, meaning that the next time it rains, the water doesn't necessarily infiltrate, you can actually get runoff. So they're consuming organic matter, they're breaking the surface or that capping. and they are an absolute tool within the landscape. I know many graziers that, you know, consider themselves to be cattle people or livestock people, and another way to look at it is being a grass farmer. And I guess the next extension beyond that is to consider yourself to be a soil farmer, and the cows are really just a tool that you're using within that system to grow more soil, to grow more grass, and to produce more beef, sheep, or whatever it is you're growing. So one of the key principles really above the ground is diversity. In fact, diversity is probably a key principle across the board. You know, whether it's above the ground or below the ground. Diversity in plants above the ground, but diversity of seed to begin with means that you're adding, every seed has its own what they call microbiome, or every seed has its own microbes that it takes with us when you plant it in the soil. The greater diversity of seeds that you're using, the more diversity of microorganisms that you're adding. The diversity of plants above the ground means you're taking up various niches. You've got some that are wide, some that are tall, so plants can all kind of live together and find their niche. And then obviously the broad spectrum nutrition that a diverse above ground planting is giving your livestock compared to a monoculture is obviously more favorable and superior from the point of view of livestock nutrition. And really, you know, depending on the system, it really doesn't matter what sort of system you're running. There's always opportunities for increasing diversity of plants above the ground, whether it's companion planting in cropping, or inter-row cropping in horticulture, or multi-species in intensive grazing, or again, cropping operations. And I guess in a grazing operation, again, it really comes back to the management of livestock through the landscape, because in most cases, particularly those of you that are on the real rangeland, you know, large hectare country, are not going to go out there and seed things. But certainly there'll be a seed bank there just waiting for the right conditions. And generally that is linked to nutrition. So if you can really get that dung and urine concentration and moving the animals through the landscape in a planned and strategic way, then you'll find that things start to germinate and pop through where you haven't necessarily needed to sow them in the first place. So that's above the ground. And then below the ground, equally, you've got this diversity of plant root systems. So, you know, rye and oats are really great fibrous root systems. They really help to build soil structure. Vetch, being a legume, is fantastic for nitrogen, but also for accessing calcium and phosphorus. Legumes release acids in the soil that liberate calcium and phosphorus from the soil profile. Mustards, they're soil biofumigants, so they'll actually kill nematodes and certain fungi that you don't want in the soil by having them in the mix. Buckwheat is listed there. That's a great one for accessing phosphorus. They scavenge phosphorus. And then radishes are awesome because they soak up a lot of, they're sort of soaker-uppers, especially nitrate nitrogen. If you've had a crop that's been had a lot of nitrate nitrogen applied, you can you know, sow a subsequent crop that includes radish, and the radishes will actually soak up a lot of that nitrogen. And then, you know, whether it's turned in or ploughed in, make that nitrogen available to the next crop. But the thing I really want to look at here is just the different plant species that are grasses, cereal, legumes, herbs, chennapods. Chennapods are things like kale and amaranth and things like that. There's 5 different species of plants, and you know, the more diversity that you can have within that plant community, some guys are doing 12, 13, you know, 20 different plant species when they're sowing multi-species cover crop. You know, the more diversity really, the better. Enemy number one, I was just talking about this before with Julian, you know, I speak about this quite often with lots of people, is that the number one enemy in no matter what sort of operation you're running, whether it's grazing or horticultural or cropping or what have you, really is bare ground. This is a fantastic photograph taken off a video, slow motion video of a raindrop hitting bare ground. And you can see those very, very fine particles up here. They're all the silt clay particles. And of course, when they're the last ones, they're the finest ones, and they're the last one to hit the surface. of the soil once this, larger portion of water settles. And then when the sun comes out, that's where you get that baking and that crusting, which, results in that capping that you'll quite often see. And again, back to the livestock, that's where they can be very useful in actually breaking up that capping, which allows then moisture to infiltrate and possibly even seeds to germinate, especially if they put a bit of dung there as well. So really the message here is number one enemy is bare ground. It's the single most destructive force that there is. It's a bit like us walking outside without a sombrero. The temperature of the soil. If you actually get one of those, what are they called? The laser temperature readers you can get from Repco. And if you go out and actually point one of them at bare ground in the heat of the day, and then you've got an area that's got either living plants or a mulch layer, and you take a reading, but then remove the mulch layer or separate the living plants and take a reading, you can find 25, 30 degrees Celsius difference between those two. And of course, that has a direct impact on the life in the soil as well. Soil life, if you're interested in looking more at sort of, the deep rabbit hole that is soil life and the interconnectedness between all of these different organisms that we don't see below the ground, probably this lady more than anyone else has done all of, the most research and work and been an advocate for soil microbes. And her name is Dr. Elaine Ingham. She founded an organization called the Soil Food Web, and this is her well kind of known slide showing the interconnectedness between all of these different microorganisms in the soil, showing how this one, does this, and then this one eats this one, and there's a whole link and a web between all of these different organisms, some of which you can see, like these arthropods, obviously birds and animals, some which have a bad reputation like nematodes, but they're not all bad nematodes. There's good nematodes as well. And then some like this one here, protozoa. Protozoa are really, really important organisms because what they do is they eat these bacteria, and these bacteria have a lot of nitrogen in them compared to what protozoa need. And when I say they eat them, they'll eat thousands of bacteria a day. So if you have a healthy protozoa population, and these little bacteria are floating around in the soil with all that nitrogen, the protozoa will eat thousands of them, take the nitrogen it needs for itself, and then release the rest of the nitrogen for plants to be able to uptake. Conversely, if you don't have protozoa in your soil for whatever reason, whether it's compaction or not enough organic matter or whatever, it doesn't really matter, but if you don't have them, then these little bacteria are floating around with all this nitrogen, but nothing's eating them to release it. So those sort of interactions are happening across the board with all of these organisms. Organic matter feeds microbes and provides them with a housing. And microbes, importantly, make minerals available to plants. So it's this circular economy where the plants are feeding the microbes and the microbes are feeding the plants. It's not a one-way street. It's very much a reciprocal relationship. And it's really vitally important to understand that plants are the ones that feed these microbes, and microbes in turn feed and protect plants. So just in terms of how many microbes there are, a coffee spoon of healthy soil contains these ridiculous numbers, which are a bit hard to get your head around, but think about 100 meters of fungi. Now, fungi, you will never see the hyphae. They're like little strands in the soil. There's 100 meters of fungi in a healthy teaspoon or a coffee spoon of soil. And those protozoa I mentioned before, 10 millions of protozoa in a coffee spoon that are eating those 100 to 150 million bacteria. And it's quite difficult to conceptualize that 1 hectare of a healthy soil contains microorganisms that can weigh the same as a Airbus, which is around 40 tons. So when you're walking across the landscape, you're walking across all this life under the soil that we don't see and we don't recognize, but you see above the ground reflected in the health of your pastures and in turn the health of your livestock. Lots of different soil tests that you can do, and I'm not sure to what extent those of you on have really looked into, soil testing and alike. But there's a laboratory that I always use down in Lismore in New South Wales, and I use them simply because they're an independent laboratory, and I get a real measured, non-biased answer to the soil test. They've got information on their website, and I think we'll send a link about them as to, conducting a soil test and the information that you get back. But the soil test that I like to do shows you, what your available minerals are. It covers the chemistry and the physical condition of your soil, but importantly, this section here tells you what the bank of minerals. So normally in a soil test, you'll just see what's available, but I always like to do the soil test that includes the totals as well. So for example, if you find that you've got a limited amount of, I don't know, zinc that is available in the soil test, but then you look at the total zinc and see that you've actually got a decent amount of zinc there, you may need to supplement a little bit if you're in a situation where you're actually supplementing or making those interventions. Again, in a broadacre kind of grazing operation, you're not going to be doing that. But for those of you who are doing this sort of thing, you can see how much is available and then look at your totals and recognize that you actually do have a bank there. In many cases, you do have a bank there, and it's really then a matter of trying to understand, well, why is this bank not available? And generally that will come down to pH and the compaction of the soil, whether the calcium or magnesium ratio is out, and then you look at the biology. So it becomes an unpacking exercise, but it is a useful one to work out, well, what's the bank that I'm sitting on, not just what's in my wallet, so to speak. There's one that I get done in the US as well. And this is, again, for intense, sort of cropping. I work a lot with sort of, 2,000-3,000 hectare cropping operations. And we'll do this Haney test, as it's known, developed by Professor Haney. And it does a couple of other interesting things that the previous test doesn't do. It's more of a realistic measure of what is actually available. So if zinc is low, for example, in the previous test, it'll be low here as well, but the amount of zinc that's shown here as being available is actually more realistic because the extraction method that they're using at this laboratory is similar to what happens in the soil. Whereas the previous one, they're using, hydrochloric acid and very strong acids that are nothing like what's in the soil. It also gives us an indication of the life in the soil with this microbial respiration. So they measure how much carbon dioxide the sample gives off over a 24-hour period. Microbes are the same as you and I. They breathe in oxygen and let out CO2. And interestingly, I think really usefully, it gives you a soil health score. So, it adds up about 7 or 8 different results from all of these numbers, and it gives you one number that is your soil health score. And you can see here that, difficult to see, but it's around 15 as a soil health score. So that's something that you can monitor over time as an actual tangible number. And then on the back of all the results here, they usually give you a recommendation of, in this case, 10% legumes and 90% grass. And that's all about balancing the food sources for the microbes. Sometimes it's 50-50, sometimes it's, 30-70, but they've always got that recommendation as to, what you could sow if you were sowing some sort of cover crop, etc. Keep on the subject of soil testing, microbiology, we're always talking about it. Well, how do we measure it? Same laboratory does this particular test, which is a DNA extraction. So this gives me a bit of a helicopter view of what the life in the soil is like. It'll give me, whether I've got protozoa eating bacteria, and you can see here that it's all bacteria, which is a very poor result. That means as I mentioned before, there's no protozoa that are eating that bacteria and cycling that nitrogen. It also gives you numbers for things like mycorrhizal fungi, which some of you may have heard of, bacteria populations, overall diversity, total populations of microbes in the soil, and then gives you a rank according to how that is. Now, if you sample at the same time of year each year, well, that compares apples with apples, and then you can monitor over time whether your microbial population is increasing, decreasing, and diversity is increasing or going backwards. Are you getting protozoa coming in or not, and so on and so forth. The last one that I do as part of a suite of soil tests is soil chromatography. And this is something I do myself. That on the left is an extremely healthy soil. This is Roundup Ready BT cotton grown soil. That's a very unhealthy soil. So soil chromatography, look, it's not the first thing that you go ahead and do, but just sort of put it in here out of interest in that the previous tests are all numbers on a page. And you kind of unpack all the numbers, whereas chromatography is pictorial. It's a picture. So you can see whether you've got a healthy soil or an unhealthy. I haven't really had time to jump into all the detail, but hopefully you can see that the one on the left is a very healthy looking one, and the one on the right, which looks quite bland and blank and dead, is literally that case. All right, the impact of soil health on pasture production. So let's have a look at this. The name of the game is photosynthesis. Farming is all about photosynthetic management. That's looking at what we're actually managing. And most of what we're managing comes for free. We've got energy from sun, we've got air, in most cases water. Some people will be paying for water, and then minerals in the soil. So 95% of the weight of the crop that you're growing is for free. However, the critical part is that 95% can only work effectively if you have that 5% mineral availability. And usually there's a limiting factor there somewhere. It could be nitrogen, it could be phosphorus, it could be zinc, it could be boron, it could be, any of them. But if you can have optimal mineral nutrition, then this activity, that is the name of the game, photosynthesis, will be optimal, and you'll produce the most amount of biomass, the most amount of sugars that are pumped into the soil to feed that underground workforce. In most cases, the limiting factor is minerals. So this is Dr. Elaine Ingham, who some of you may have heard of, who talks about the, 6 essential ingredients for soil formation. So starting at the top, biologically available minerals. So it's not just okay to have the minerals there, they need to be available. And generally biologically available means the right environment for the microbes to thrive. You need air, which typically means you need the right environment so the microbes can breathe. If the soil is too compacted, and a lot of the high magnesium soils tend to be quite tight, there's not enough oxygen coming in, so those microbes can't breathe in the oxygen and let out CO2. So they need oxygen to be able to thrive. Number 3, water really is about water infiltration. How effective is the rain that's falling on the landscape? Calculate, and there's, tests that you can do for this. Calculate the rate at which water actually infiltrates into the soil. Are you getting 4 to 6 inches of infiltration an hour, or is it only 1 or 2 inches and the rest is running off? So water infiltration is absolutely critical. Not so much how much water falls on the landscape, but how much water is held within the landscape. And that really comes down to that physical chemistry and biological structure and balance within the soil that enables the soil to accept water. Living things in the soil, so their plant roots and the microorganisms that we're talking about, as well as all of their byproducts, worm pee and worm pee or micro pee and poo, those sorts of things, and living things on the soil. So that's plants and animals. So that's all the crops that you're growing, as well as any livestock that you have moving through the landscape. And last of all, there, really critical part is grazing management, that intermittent patchy disturbance regime, so that you're actually managing the plants that are growing on the surface of the landscape so that they can then perform their best the following season. And there's a lot of information out there about that, some of which I'll touch on a little bit later. So here's a comparison here side by side, and what we've got to reflect on here is kind of on the left, I've got an example there of just, like a thistle growing or pasture production. From a chemistry point of view, maybe a mineral imbalance. Physically, definitely tight. You look at the root system on that thistle plant, it will be quite taprooty, so it's trying to open up the soil. Perhaps limited organic matter could be another limiting factor there. Generally, biologically, if a soil is tight, it tends to be bacterial dominant. You don't have enough fungi, which as a result then means that you don't have adequate root development, and there's limited access for minerals and for growth. On the opposite side there, we've got an example of a really nice looking, healthy, diverse pasture. It tends to suggest that from a chemistry standpoint, there's mineral balance. From a physical standpoint, there's probably decent organic matter with lots of air, which means the biological activity in the soil of those microorganisms is very good. They're very active. We've probably got pretty good root development under the ground, and there's access therefore to a lot of minerals and moisture for adequate growth. So just thought I'd throw in a bit of a change here, just throw in a slide about land formation options, because the number one tool to use is really livestock in terms of changing the landscape before we jump into graders and some of the other options that are out there if you do have some issues with erosion, for example, in a rangeland type environment. But livestock would have to be the number one tool in terms of managing the landscape as a precursor to not get erosive forces, so you don't have to use some of those other tools. The animals are absolutely number one. And in terms of the different grazing management courses that are available, there are a multitude. There's RCS, which many of you have heard of, Terry McCosker, the Savory Institute, Alan Savory, who was the founder or the guy who developed holistic management. There's HMI, there's grazing best practice, which is Mick Alexander down in the central Queensland. There's ProGraze, which is an MLA member driven one. There's so many different ones. A couple of photos I'll just show you here. The one on the left, you can almost see a batch latch. You see these animals are so tightly packed, and they've got a bit of roughage back there because what they're on is pretty lush pasture. And so this bat latch here, and this is quite an intensive operation, obviously, but this bat latch here will make a noise and spring open, and the livestock will file on through and start grazing. So you would sort of look at this and go, well, gee, that's pretty heavily stocked, but those animals might only be there for an hour or so, and then they'll move on to the next. The photograph on the right is a classic example from Alan Savory, the Savory Institute's website. This is holistically managed rangeland environment, and on the right, I believe, is either a non-holistically managed or a national park. And the moment you remove animals from the landscape, which is quite often the case in a lot of these places in America in particular, where they, save the landscape by removing the animals, it actually has a detriment to the landscape. And there's slowly but surely a bit of a shift going back there. And a classic of that is Yellowstone, where they removed the wolves and they found the landscape degraded, and now they're bringing them back in for that reason, which is kind of fascinating. Management is really what makes the difference between these two. You've got a fence line running down the middle. This is in Africa from the Holistic Management Savory Institute. On the left-hand side is without holistic management. You can see there's quite a lot of bare ground. And on the right-hand side, you can see a pretty dense, diverse covering of the soil, and that's ready, obviously for, a pretty good feed bank there, and that will need to be grazed down so that next year's growth can actually come through. If that's left like that, then quite obviously you won't get those new plant, growth points accessing the sunlight so that they can, and there's lots of examples of this around the globe of these forms of management working in real life examples if you do some search online. This is an interesting technique. Actually, a friend of mine, Roger Savory, Alan Savory's son, that I did a bit of work with a few of the NRMs in the region. This is Strathalbyn Station, where they had an alluvial gully site that was eroding, and they did what Roger calls biological carpeting. So they did that to re-establish a vegetative cover to stabilize the whole site. So rather than using machinery, they used, bales of hay and camped cattle on there. So 800 head camped on 1 hectare site across 8 days back in December 2018. Hay and manure was then evenly spread. Reseeded as well, reseeded and with the hay and manure spread. And then you've got these photos here, the project site following 200 mil of rain. That's the top photo, the main project area with the control area in the top right, which is still bare. And then the bottom photo is the control area here on the left, and shows that now you've got a pretty stable landscape. So he calls it biological carpeting because it's really like kind of a kickstart to the whole system. Yes, it's a little bit of intervention. Yes, there's some fencing. Yes, there's some seeding and there's some hay. But once that's done, then, you know, after a decent rainfall season, then you're back into rotation, and this area then just becomes part of the normal grazing rotation for the property. So this is one at Strathalbyn Station, another one that he did with the Natural Resource Management Group down there, Inku Dry Tropics, is a really good one at Glen Alpine Station, which was a very similar type thing with an eroding gully that they parked many head of cattle on for 7 nights straight. They grazed out during the day, came back at night, laid about 2 inches of dung and urine. And then what came back was, I remember going to a field day there was, you know, 200 or 300 people or something. And people from the area were arguing as to whether it was actually Townsville lucerne that was growing through, because they hadn't seen it for 20 or 30 years. So you really biologically kind of kickstart the whole system by doing something like that. So it just sort of epitomizes the power of livestock in regenerating the landscape by doing something, you know, and the key really is stock density. That's the answer. Now, as I said, cattle are kind of the first port of call, but if you do have an issue and you need to do some form of intervention to prevent erosion from getting worse, well, then there's a few different options that I just wanted to share with you. And the first thing to say is it really, and I won't go into all the detail in this, but I'll just say that what type of intervention you would do really depends on where you sit within the landscape. So if you're talking about a really steep area up in the higher slopes, that's going to be a different type of intervention. That's going to be a different type of intervention than if you're down on the alluvial flats. A lot of the erosion forces tend to happen around this sort of change of slope area. Once you get a bit of speed run up with water, and then you get maybe a head cut, and that keeps on incising and heading back up this way, or you see unzipping of the land through this channel sort of section. So these are a whole range of different structures that you can look at building. This is a very simple one. This is Tabletop Station in Collinsville, where it's, you know, simply just a small rock wall that's only 2 or 3 rocks, and you can see the amount of sediment that's grown there. And obviously the hope is then that, you know, you would get some seeds that have fallen in here, or, you know, you get plant species starting to grow. So this then stabilizes and stops the erosion that would have been migrating up this way. So we're collecting all that silt and sand. So that's a real simple hand-built structure. This is one over here in Mariba Dimbula where there was quite a bit of erosion here that was coming from an old cart track that runs through the property. And the main project site was actually further down lower in the landscape. But just for a bit of fun, we thought, well, why don't we use all of these saplings? Don't try to fix this, because you'll spend, you know, how much money to really get what gain out of it. Let's just chop a few of these saplings down. Look at how they're actually laid on the ground as well. That's really important. They're laid on the ground with the trunk facing towards the erosion. So they're going to capture any silt or sediment that runs off this erosion. So we're basically using the erosion, letting that go, because that'll eventually kind of get to some sort of angle where plants will grow, rather than spending all that money and just chopping down a few saplings, laying them down. This wasn't seeded at all, but I can't tell you how long that was. It was long enough for, you know, obviously those plants to break down, etc. But look at that right there, where it hasn't been seeded, and all these plant species have popped up simply because we've trapped a little bit of the soil that's coming off this erosion site. So sometimes you don't need to spend a lot of money to fix some of these areas. And look, I recognise this is only a very small example, but, you know, there's a lot of saplings there. And that whole area could really be treated in a similar way with the same effect. Now, one of the main sites here, again, this is a hand-built structure, was this erosion there was a gully running through here. Well, not so much a gully, but a water course that was running through here, and the water dropped over this little fall, and that was cutting, and heading the direction of this blue line here. So what was built there was a Zuni bowl, which is just a terminology used from the people who developed it. There's a Native American tribe in the United States that built this kind of structure. You can look this up. There's a few of them around the area. One at Tolga there, quite a large one that's been built by the same guy, our erosion expert that we were working with for quite a number of years. Craig Sponholtz is his name. And this was hand built in a few hours, probably half a day, by a bunch of people, and that's completely stabilized that area. And you won't get grass growing in there, but you won't have that migration of that head cut heading further into the landscape. In the case where we didn't have any rocks, we actually made rocks using hessian bags and concrete and soil. And it's exactly the same thing. You can see here, there's a bit of a head cut, and that's just going to keep on moving. So we did a bit of remedial work and then started packing all of these hessian sacks. And that's what it looked like at the end of the day. It's essentially exactly the same structure, just made out of hessian sacks. I tried to get a photo to see what that looks like, followed up, but the property's since been sold. So unfortunately, I can't get it, but it is down near Collinsville. If anyone knows where that might be. I put this in here as well because, not all of us are going to go out and do hand build structures. Some of us have got much larger areas we need to deal with. And I just wanted to put this guy's name in, Daryl Hill, who I'm not sure how active he is in this immediate region, but he's certainly worked a lot around this area. And he does erosion control courses using large machinery. So I guess you could say this is maybe, like a woo boy type scenario, like, how to look after your roads and actually run the water off in a safe, manageable way, etc. But Daryl does whole courses on using large scale equipment to manage for water moving through the landscape, particularly when it's been causing, erosion problems. There's an example of it that I think Terrain NRM did, a large scale example, a lot more expensive, obviously, these large scale options. I mean, this one here was funded. There's a lot of rock and there's a lot of material that's brought in. And again, the best prevention of erosion is obviously grazing management. So this doesn't happen in the first place. And that's kind of the finished product of what it looked like. So, it's water coming off a road and causing kind of this cut that's occurred, and it just gets bigger over time. So this kind of all stabilizes it all. But it's a very, very expensive exercise. And I thought it was interesting. You can see this trailing that's happening here with the landscape. That's almost the beginning of another erosion that can occur, because once you get livestock obviously trailing, they're creating this little runnel, and with the amount of rain that we can oftentimes get in the region, that can then turn into something like that. So it's just something to look out for and prevent before having to spend a whole lot of money. Diversity in grazing plant management. So enough about the erosion stuff, but back to kind of multi-species cover cropping. Being able to have a whole diverse sward of plants growing within on top of the ground means that you've obviously got a range of different root systems below the ground. So introducing this diverse community of plants enhances kind of resilience within your pasture and productivity. It also means that the animals have a broader plane of nutrition. Obviously needs, proper management practice, rotational grazing, and a few of those things that I mentioned there before of the different educational organizations that do training and that type of thing. Covering the ground, not having those bare patches. And there's a gentleman by the name of Dick Richardson who does a lot of holistic management training within this region, who would be one of the people that I'd highly recommend that you maybe inquire about and have a look at. And he's got some really, really good resources and does a lot of training around grazing management to help with this. So the healthier the soil is, the more diverse the plant species are going to be above the ground. So with the healthier the soil is and the greater the diversity of plant species, it generally means that you've got this greater nutritional availability. So plant species diversity equals nutritional diversity, and we're in the market, many of us, making money by putting weight on livestock. So the broader plane of nutrition that those animals that can be on, the better. I know that down in the Fitzroy Basin Association, dieback was a particular issue, and there's a lot of theories around why dieback actually may occur. And I'll throw my 2 cents in there and think that dieback, it's probably as a result, or could be a result of many, many years of monoculture grasses being grown, because of the monoculture grass being grown for its livestock nutrition and the weight gain that it puts on. But again, when you've got a monoculture, you don't necessarily have all of the microbial species to actually access different minerals and protect plants, and pathogens can build up over time. And that could be one of the reasons why, as a result of 30, 40 years of monoculture, that we're now starting to get, some of these, diseases or these issues like dieback, which could be a direct result, in my opinion, from the lack of diversity. So below the ground, health is always reflected above the ground. So if you see really, really good things above the ground with lots of different plant species and really healthy looking pasture, then below the ground, that's indicative of what's happening below. Equally, if you have, yellowing and not much diversity and a lot of bare patches and alike, you'll generally find that below the ground is reflected in that same way. So what happens below merely reflects what's happening above. And, healthy pastures, they obviously attribute to, overall live weight gain, energy conversion. If an animal can actually eat less to get more nutrition, that works for everybody. That's what we would all want. If they're having to eat more and more and more to get their nutrition, they're obviously going through feed a lot quicker. Then that's not favorable for the economics of an operation. It's no different than you and I. 40 years ago, we might have been able to eat one of grandma's tomatoes to get the amount of nutrition from a tomato, whereas now we might need to eat 4 because the overall nutrition of our food is diminished in most cases. So it's no different with an animal. The wider plane in nutrition, less feed, better digestibility, more weight gain, and that all comes down to the diversity above the ground, reflected by the diversity below the ground. And subsequently, again, like you and I, if we're eating a healthy diet, less disease and other health issues, the function of the rumen, that vessel that the animal ferments all of that grass, and the microbes in the rumen extract all of the goodness out of it. And then lick blocks and, supplements and those sort of things, they can kind of bridge short-term or medium-term deficiencies. And I know in many areas, phosphorus, for example, is one of those things that's quite deficient. So, they play their role, but it's not kind of the main game. Obviously, you want most of the nutrition coming out of the grasses, etc., that they're eating. And, the opposite of that is, poor pastures on it, obviously leading to deficiencies in the plants, leading to deficiencies in the livestock that are consuming those plants. And, you've got more disease, more issues, pregnancy issues, being able to hold calves and all of those sorts of things. All sort of obvious stuff. Regenerative farming practices for soil health. I just wanted to touch on just a few things here, a little bit more detail. Grazing land and financial management, which is holistic management that I referred to previously, or RCS, or any of those grazing type. They're not just grazing educational courses. They also obviously speak to land management in general, but also financial management and so on and so forth. Keyline is another one that I'll touch on. Many of you may be familiar with, is a famous Australian invention, the keyline, or the yeoman's plough. P.A. Yeoman developed the whole keyline system. Then another Australian invention, pasture cropping, which very much goes in hand with no-till farming, and then cover cropping. So this is the holistic management model for decision making. And I know that it looks quite complex if it's the first time that you've had a look at it and so on, but this is really fundamental to the use of holistic management, again, RCS and grazing. They all have very similar versions thereof. It's really fundamental to the whole process, because first and foremost, it's a decision-making framework. And there's a lot of testing questions. That's what this section is here. There's testing questions within the decisions that you're making. Once you've, done a whole lot of work to work a lot of this stuff out, this is the one line here that I wanted to kind of draw the attention to, in that it's very useful in terms of making decisions once you've done some of the pre-work of, working out who the decision makers are, whether grandpa has veto power, what money you have available, and so on and so forth. So the cause and effect, does this action that I'm about to take actually address the root cause of the problem, or is it really just addressing the symptom of the issue? The weak link question, if I take this action, am I going to create a problem with my neighbor? Does this action address the weak point in the life cycle of the organism you're trying to control? That's a biological question. And on a financial weak link, does this action strengthen the weakest link in the chain of production of my operation? Marginal reaction is always a really important one, because, what's going to give me the most bang for my buck? Is this decision I'm about to make actually going to get me a return on my investment? And the example there I'll use is the one of the erosion. Huge amount of money that could be spent in fixing erosion issues, but what's the actual return on the investment? Is it going to give you back the money that you've spent? Gross profit analysis, obviously very important. What's going to cover the overheads of this business? Use this test when you're comparing sort of two or more enterprises in terms of making a decision. Energy, money, source and use. Where's the money coming from? Are we borrowing it? Is it money we've got in our bank? Which way is it going to take us towards where we've said we want to go in our statement or purpose, or is it going to take us away? Sustainability, is it going to lead us towards, again, where we said we want to go, or is it going to take us away from that? And then I think the last one's kind of the most critical one, is kind of a society and culture. That's more of a gut feeling. Like, how do you feel about the action? So once you go through all your testing questions to kind of work out whether you should go this way or go that way, or you're faced with the decision about whether to buy the new tractor or spend money on the erosion and you can get to this final one and decide, how do you feel about it? Is it going to, again, lead you towards where you say, we've all agreed that we want to go? Is it going to affect the lives of anybody else, our neighbors, and so on? And anyway, it's a really, really, really interesting and very useful decision-making framework that takes quite a bit of work to set up, but I would highly recommend that as something to look at that goes beyond just grazing enterprises. It's really for any type of system that you're running. Keyline's the other one that I mentioned, and Keyline's really a land planning tool. And P.A. Yeomans, who's the inventor of the Yeomans plow, which many people are familiar with in relation to Keyline, he created this sort of land planning tool in terms of the scale of permanence of these different things. So when you come to designing your farm or your land holding, or whether it's an existing property or one that you're about to buy in the future or what have you, the scale of the permanence of these different things varies. So right down the bottom, soil is the easiest thing to lose, and it's the easiest thing to build in terms of time, and how long it can stay around for, and the amount of energy that it can take. Whereas something like road and access, there's a lot of diesel, there's machinery, they're going to be there for a very long time, and so on. And then climate is obviously at the top. It's the hardest thing to change. Generally, the climate of where you are is the climate that you've got. It's a very difficult thing to change. Land shape as well, very difficult thing to change. It's influenced by the climate of where we live and the amount of rainfall we get, etc. I mean, a D9 can move a lot of soil around, but again, it's pretty permanent once you've done that work. And then water is as a result of this climate and land shape. And then roads and access are, again, the next step down for permanence. Trees, once they're planted, they're kind of pretty permanent. Structures, they can be moved or torn down, etc. And obviously subdivision and fencing is, again, less permanent and at the bottom, soil. So he used this land planning sort of framework, or this tool, to decide as a framework for actually designing properties. And what you do is you start at the top and work your way this way. So when we bought our property, which is only a small acreage property, we spent a year observing the climate and looking at the land shape before we started to think about how we were going to harvest water from the landscape, because we needed to see, what the rainfall patterns were, or what the landscape kind of did when it did rain. And then we put in our water harvesting infrastructure, and then we put in our roads, and then we put in our trees, and then we put in our house. So it's used in that kind of way, and it's a very useful thing. And this is the keyline plow. This is a non-subsoil inverter. So it's very useful in kind of intensive operations. It's been used up here. I know some people have got them up here. There's a little bit of, information around how you should appropriately use them. They're not deep rippers. You're only really wanting to go 6 to 8 inches deep just to break through that kind of compaction layer so you can get air and moisture into the soil. This one here's got a little roller on it as well, so you just flatten out some of these cuts that these shanks are making. And this is the you got the knife or the cutter wheel in front. And there's your rigid tine, and the magic's really in this. This is where the money is. Any kind of rigid plow implement can be converted into one of these simply by buying this attachment that can slot onto it. Because when it does move through the landscape, you can see how there's almost like a surgeon's knife there, but under the ground, you've got this fracturing that's occurring. So it's not a smooth surface that's actually creating a lamination under the surface, or a glazing, because you wouldn't want that, because you want air and moisture and root systems to go in. That shoe is actually got little ridges and indentations on it. So as it moves through the landscape, it actually fractures and creates a nice aerated kind of environment, which, thereafter you can have, better root development and growth. So this is a bit of a schematic, if you like, of, starting with, compacted shallow root systems and short plants. First year you come through, you're kind of going 6 inches down, then root systems can develop that far over the course of one growing season. The next year you may come back and go another 2 inches below that, and so on and so forth. And by the time you're dropping it down to 20 inches or so, you might as well sell it to your neighbors, because you don't need it anymore. So it's a really good sort of mechanical intervention, but in no way replaces the effectiveness and the benefit of having livestock, because the plow doesn't consume those plants that are grown on top, and they also don't have the plow that can distribute that dung and urine. But the combination of the two, where it's appropriate to use it, can be very, very effective. This is pasture cropping developed by a gentleman by the name of Colin Seiss and his friend Bruce Clough. They looked out from the back of the porch and said, well, why are we killing all of those summer grasses with herbicide to sow our winter crop when the summer grasses are going to die anyway? Cut a long story short, many, many years of refinement and developing of the whole system. And I should say that he developed the whole idea on the back of crisis. They were forced into a situation, financially, they were burnt out, etc., but they had to do something different. And that's where he came up with the idea of pasture cropping. So in essence, what it is growing a winter active crop in dormant perennial pastures. So he's actually down in Goulgong in New South Wales, so a very different environment. I agree. The principles I think we can draw from no matter where we are, and there's many examples of pasture cropping happening all over the world, but here you see summer active grasses that are coming through as he takes off the winter crop, and he uses large mobs of sheep to move through the landscape as well in a very integrated sort of system. And I think he's got something like 76 different varieties of native grasses that are now part of his perennial pastures, and he hasn't sown one of them. And that's also forms very much part of his income stream now, is selling native grass seed. So, how can he have that many different species of these things coming through when he hasn't sown any of them? Is because a lot of these native species of grasses live for, they lay dormant for, hundreds of years. Kangaroo grass, wallaby grass, themata, that can live for 500 years. So a lot of these seeds are sitting there laying dormant in the soil. And the reason they're not germinating is because the conditions aren't right. And so once you change the conditions, then, these seeds with a bit of moisture can, boom, up they go. So you'll see this succession happen over time. as Colin has seen here. And it's a really, really well-studied property, and partly because his brother is his neighbour, and there's a fence line down between the two of them. And his brother's a very good farmer, but he's conventional in what he's doing. And this is his property this is a soil core from his property on the right-hand side, his brother's property. You can see a little bit of dark soil at the top. It's pretty decent. Like he's got some good topsoil there. But then you look at Colin's, and the darkness and the friability and the structure of the soil, you can see goes, far, far deeper. And the current climate, if he was getting paid for soil carbon, that would be a pretty good operation to be making money on. I've got a couple of minutes left. I've only got 3 or 4 more slides. This is what I was referring to before in the difference of effective and non-effective rainfall. So if you think of 1 mil is 1 litre on 1 square metre, in a 600 mil rainfall area, that's 3 44 gallon drums per square metre, or 30,000 drums per hectare, or 6 million litres per hectare. So quite often it's not that we're not getting enough rain, it's just that the rain that we're getting, we can't make effective because of the condition of the landscape that is unable to accept the water. And again, if you've got livestock, you're in a very fortunate position, and you've got the #1 tool to change this into this through the management of the movement of those animals through the landscape, because that's the thing that's going to bring about better soil health with more diverse plant species, not necessarily sowing anything, so that you've got that increased organic matter that then means you get more infiltration, more water holding capacity. So in the dry times, you can kind of hang on a little bit longer, as well as during the really, really wet times where you're not so waterlogged, that you're actually absorbing and utilizing a lot of that. 1% increase per hectare is about 144,000 litres that your soil can hold. So you don't have to shift the needle too much to really get good water holding capacity. Just the last couple of slides here. This is a 50 species, multi-species cover crop. This is Gabe Brown, a gentleman in the United States. He does this to manage soil erosion, soil fertility, soil quality, water infiltration, control weeds, pests and disease, and also biodiversity. Brings a lot of wildlife in. He runs a pretty sweet setup, and this is his livestock. He's quite often different ways of sowing it. Sometimes he'll use the livestock to get the land looking like this, and then he'll sow it. Other times he'll actually have a standing crop and broadcast the seed in front, and then have the livestock move through. So you got 800 head, that's 3,200 feet, and quite a few kilograms that can work that seed into the soil. So there's a few different ways, a bit like that erosion example that I showed before. That's kind of how they did it there. And there's an example of one of his multi-species covers that, that's ready for high density grazing, quite a bit of protein in the sunflowers, etc. There's a lot of online resources, and I'm sure you'll get a copy of what we've got here. But there's just a few links to the different institutions for grazing land management and the like that I showed earlier, the keyline stuff, a bit of erosion. This is mainly the kind of hand-built stuff and some of the smaller scale kind of structure. And there's a link to a friend or a past client of mine, a friend of mine, Grant Sims, who runs a company selling multi-species cover crop seed. And he's a really, really valuable source of information. He's doing it himself. He's a farmer, 7th generation, decided to start a business in selling multi-species seed mixes because there was just so much demand for it and no one was doing it. So contact him for a seed mix. And I've also given a little bit of a reading list of various things, from microbes to interesting stories about, agriculture, to Gabe Brown's book, a bit of animal and soil fertility. That Sunday night reading, if you're so interested in, that you would like to read something, there's the Keyline book, the work of yeomans, etc. And a couple more links here, one here to the pasture cropping site. Soils for Life is a really good institution, Australia-based, and the Soil Food Web, which is Dr. Elaine Ingham, the Microbe Lady's website. And thank you. I've gone over